Hello everyone, you are welcome to class today. All right, today we are going to be looking at set theory. The last time we discussed about the definition of set theory, and we looked at one or two examples. Now today we are going to continue from where we stopped. Don't forget the last time I defined set as a collection of well-defined items. Set is a collection of well-defined items, and we looked at several types of set of numbers. We looked at natural numbers, which are counting numbers, and integers, composite number, even numbers, prime numbers, perfect square, and so on. Now today, we are going to be looking at some set of questions today. Now, based on our last discussion. Now let's look at the example we have here, example 1. Right? So, okay, but before we do this, I will want you to get your writing materials because we are going to be working together today. So it's going to be a fun, and I will want everybody to participate in today's class. So tell someone that the class has started. Tell your friends, let them know that the class has started. All right, let's go on now. Okay, the first question we have here now, let A be the set of natural numbers less than 5. B, the set of prime numbers less than 15. C, the set of perfect squares. D, the set of multiples of 3 less than 20. Now, the last one, which is E, the set of composite numbers less than 10. Okay, now the question asks us to list members of set A, B, C, D, and E. So how do we go about this? Now, let's start with the first one, which is set A. Now look at what we have here. A is a set of natural numbers less than 5. Natural numbers less than 5. Don't forget the last time we defined natural numbers as counting number. Okay, if you want to count something, you start from 1, 2, 3, 4. So counting numbers start from 1. And don't include 0 because you don't make a count of 0. All right, so now there's the set of 1, 2, 3, 4, 5, 6, and so on. Now look at what you have here. This one is well defined, and that's what we call sets. Now, set of natural numbers less than 5. So I'm listing natural numbers that are less than 5. So the first of the natural number is 1, followed by 2, followed by 3, and 4. All of these are less than 5, and they are natural numbers. Okay, so that answers this first one. Now let's look at the second one, B. Now, what do we have? B is the set of prime numbers less than 15. You see, I must know what a prime number is. Now, what do we call prime number the last time we defined it? We said prime numbers are natural numbers that are only two distinct divisors or only two distinct factors. Okay? All right. So now the list of prime number now is 2. So now we have to list prime numbers less than 15. Now the first prime number is what? Can you tell me? That is 2. Now don't say 1 because 1 do not have two distinct divisors. Okay, so the first one is 2, followed by what? 3, followed by what? 5, followed by what? 7, followed by what? 11. Don't forget, we are not going beyond 15, followed by what? Followed by 13. Okay? Now, these are prime numbers that are less than 15. Okay, so you have listed it. And don't forget, when listing members of a set, make sure you put the members in a curly bracket. They must be enclosed in a curly bracket. Otherwise, it's not a set. So let's take note of this. Now let's look at the third one. Now, set of perfect squares. Set of perfect squares. Now, perfect squares are natural number whose square roots are integers. Okay, so now the list of the perfect square is what? Is anybody telling me? All right, the list of perfect square is 1, because when you find square root of 1, you're going to have an integer. All right, so now, so the list is 1, followed by what? We have 4, followed by what? We have 9. All of these numbers, when you find their square roots, you're going to have whole number, okay, and so on. Now, you can see, because here, we are not giving a limit. So we just have perfect squares. So it continues. So after 9, we have 16, followed by 25, 36, and so on. Okay? Now, let's look at the next one. Now, D is a set of what? D is a set of multiple of 3 less than 20. Multiple of 3 less than 20. When we say multiple of 3, now if I write only 1 3, it's just 1. If I write 6, 6 is multiple of 3. How many 3s do we have there? We have 2. So another multiple of 3 will be what? Can you tell me? Now that's 9. So we have 3 3s there. Another multiple of 3 will be what? That's 12. How many 3s do we have there? We have 4. So now we have to list multiple of 3 less than 20. So now let's start with the first one. We have 3, followed by what? 6, followed by what? 9, followed by what? 12, followed by what? 15. Then we have 18. Now the next one is 21. But don't forget, what we are listing must be less than 20, so we have to stop here. And you can see the beauty of definition of a set. Suppose this is not divine, we'll just be listing. Okay, so this one now have constrained us to this set of numbers. All right. Okay, now let's move to the next one. E, set of composite numbers less than 10. Set of composite number less than 10. Now, what do we call composite number? Composite numbers are natural numbers that have more than 2 divisors. Okay, so the list of the composite number is 4. 4 have 3, it has 3 divisors. So we have 4 itself, we have 2, and then we also have 1. All right, so now, so the list is 4. Can you tell me after 4, what do we have next? All right, so that is going to be 6. Now, we have 8. We have 9. So we can't go beyond that because less than 10. All right, so all of these are composite number less than what? Less than 10. Okay, good. So we have done the first part of the question. Now the next thing now is to find number of elements in set C and number of elements in set E. All right, so when you have this symbol, it means this N means number of elements in set C. All right, so now let's do that. The first one, number of elements in set C. What does it mean? Now you should go straight to set C and count the number of elements we have inside. All right, so now when you look at set C, you cannot count all the elements, so it's uncountable. All right, so because the set here is infinite, so we have, perfect square, we have perfect square, we have here now, we have 16, we have 25, we have 36, 49, and so on. So they continue like that. So now you cannot count all the elements. So in this case now, number of elements here is going to be infinite. So it's going to be infinity. So look at this symbol now. So uncountable. So this is infinity. So that is the number of elements we have in set C. So you cannot count all the elements we have inside. All right, so that's going to be the answer. Now let's look at the second one. Okay, number of elements in set E. So I want you to do this and tell me the answer. So somebody should do that and tell me the answer. You drop the answer in the comment section. So let me wait and see what some of us have here. Number of elements in set E. Yes. What is the number of elements in set E? Number of elements in set E. I'm waiting for responses. Okay. Okay, is anybody dropping anything? All right. Okay, so number of elements in set E. Now let's just go straight to set E and make a count. 1, 2, 3, 4. So you count the number. So we have 1, 2, 3, 4. That's all. So the answer is 4. And that is the answer to this problem. Now suppose this is given in an exam. Now for listing each of member of each set, so there will be a block mark B1 for this, B1, 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 A1, A1. Okay, so this so how many marks? 1, 2, 3, 4, 5, 6, 7. So you have 7 marks altogether for that question. All right, so I'm going to give us the part B of the question. So now let's look at this. Now decide whether true, whether the following, is or are true or false. Okay, so we have the first one, A equals to D, B, number of elements in B equals to number of elements in D, C, A is a member of C, B, okay, now let us look at what we have on the board. Now you have to decide whether the following is or are true or false. Now look at it. Now what we have here is set A equals to set B. Now we must understand when two sets are equal. So two sets are equal if they have the same elements in them. So two sets are equal if they have the same element. So if you know that definition, so you can decide whether this relationship is true or false. Now we have set A equals to set D. Can we see? Now set A equals to set. It's obvious now that they are not equal because what we have here, not everything is A. So that means they are not equal. So the answer to this is false. Okay? Now let's look at the second one. So number of elements in set B is equals to number of elements in set D. So we want to see if they are the same thing. Let's see the validity. So let's count the number of elements in set B. So let's see number of elements in set B. How many do we have? 1, 2, 3, 4, 5, 6. So that is 6. Number of elements in set D. Now let's count how many. 1, 2, 3, 4, 5, 6. Good. So that means number of elements in set B equals to number of elements in D. So that implies that the relationship is what? Is true. So the answer is true. Okay? Now let's look at the next one. Now look at this symbol. What does it mean? It means member of. So now to read this, now we have 9 is a member of set C. 9 is a member of set C. That is, 9 is an element in set C. So let's see the validity of that statement. 9 is an element in set C. So you just go straight to set C. Do we have 9 here? Yes, we have 9. So that means this statement is true. So the answer is true. True. All right. So now let's look at the last one here. Number of elements in set E equals to 5. Number of elements in set E equals to 5. So true or false? True or false? Now, I want you to give me your answer before we do it. It's very simple. So true or false? D. Let me check what we have here. True or false? Yes. Number of elements in set E equals to 5. True or false? True or false? Okay. I'm seeing true here. I'm also seeing false. I'm seeing true, false. Oh. All right. So now let's look at it now. Let's look at it together. It's very simple. Now, number of elements in set E. So just go straight to set E and count the number of elements we have inside. So now let's do it together. We have 1, 2, 3, 4. So the number of elements in set E is 4. So which negates this? So that means this claim is false. So the answer is false. So this question, we attract 1 mark for answering this correctly, 1 mark here, 1 mark here, and 1 mark. So we have 4 marks for this answer. All right. I want to believe you are learning. And don't forget, if you observe that your friend is not online, try and invite your friend. Okay. So now, let us move down to another thing. So I want you to try this and tell me what you have. Try this. Let's quickly try this. So I told you to get your writing material. So you may have to write. After getting your answer, you drop it in the comment section. So now let's R to be equals to the set of multiple of 5, multiple of 5, multiple of 5 less than 30, multiple of 5 less than 30. Okay, and then we have S to be the set of perfect square. Perfect squares. Perfect squares less than 20. And the last one, P is the set of composite number. Composite numbers less than 4. Okay, so now This is the question. Find, first one, number of elements in set R. The second, number of elements in set S. And the third one, number of elements in set P. Can we quickly do this and drop our answer in the comment section? So this is the question. So this is based on what we just did now. I want you to try this and drop your answer in the comment section. All right. Okay, so let me begin to view our answers. Okay. Okay. So what do we have? Let's drop our answers. Number of elements in set R, number of elements in set S, and number of elements in set P. Okay, I want to believe by now we should have finished. So now let's try and look at it together now. Set R. Let's look at set R. Now, is the multiple of 5. Set R is multiple of 5. So multiple of 5, we have 5, 10, 15, 20, 25. So you can't go beyond this because multiple of 5 less than 30. So all of these are less than 30 and they are also multiple of 5. Now let's look at this. Perfect square less than 20. Now let's list that one out. Perfect square, we have the list is 1, 4, 9, 16. Now the next one is 25. But we have to list perfect square less than 20. Okay, now let's look at the last one. Composite number less than 4. Composite number less than 4 is going to be an empty set. Okay, because the list of the composite number is what? Is 4. So we have to list composite number less than 4. So that means there will not be any element in the set. So it's going to be a null set. Okay, so the question now wants us to find number of elements in set R. So number of elements in set R will be, so just come down to R here and count the number of elements we have inside. We have 1, 2, 3, 4, 5. So the answer is 5. So that's the first one. Now the second one, number of elements in set S. Go to set S and count. So we have what? 1, 2, 3, 4. So we have 4. And the third one, number of elements in set P. Now you come to set P. It's a null set. So number of elements in set P is what? That's 0. Okay, so this is the answer to this problem. Okay, so if you get the answer to this problem before I solved it, let me know in the comment section. So now let's move down to another question. Now let's move down to example 2. Example 2. Example 2. Example 2. So what do we have there? Let's call it you with a set of 1, 2, 3 down until we get to 10, and be the universal set and A be the set of odd numbers between 2 and 5. Odd number between 2 and 8. 2 and 8. B, set of perfect square greater than 1. Set of perfect squares. Perfect square greater than 1. Greater than 1. Okay. Now this is the question. List members of sets A and B. 2. Find A complement, B complement, C B complement, D all subsets of B. All right. Okay, so now this is the question. Now let's call you be the set of 1, 2 down to 10. Be the universal set, and A being the set of odd numbers between 2 and 8. B is the set of perfect squares greater than 1. Now, the question is list members of sets A and set B, and also find A complement. So this symbol means complement, and the B complement, C complement, and all subsets of B. Now, before we solve this question, let's quickly remind ourselves some basic things we are supposed to know to answer this question. Now, the first thing is the universal set. Now, the universal set is a bigger set that contains all sets under consideration. It's a bigger set that contains under consideration. Now, let me give you an instance. If we are looking at a set of states, and now we begin to list Ogun State, Lagos State, Kwara State, and so on. Now, we all know that the universal set that is containing all these sets is going to be what? Nigeria. So Nigeria is going to be the universal set containing all these sets. Right? So, and you can see the idea of a universal set. Now, the implication of that is that you cannot have a member of Ogun State, for instance, that we say is not in Nigeria. Do you understand that? Because Ogun State is a subset of Nigeria. Ogun State is inside Nigeria. So it's not possible for me to say I'm from Ogun State, but I'm not from Nigeria. So, because if I'm from Ogun State, that means that I'm going to be a Nigerian. All right? Good. So that is the universal set. Now, look at this question. Now, complement of set A. Complement of set A. When we say complement of set A, what it means is those elements that are not in set A but are inside the universal set is what we call complement of set A. Now look at this one, set B. There are those elements that are not in set B, but they are in what? The universal set. Hope you get that. Good. So, now let's start with the question. Now the first one, we have to list member of set A and set B. Now, set A is the set of odd numbers less than odd numbers between 2 and 8. Now we must know the definition of odd numbers. Odd numbers are natural numbers that are divisible, that are not divisible by 2. Okay, all right. So now the list in this set now is going to be what? 3. 3. The next one is 5, followed by what? 7. So the next one is 9, but 9 is not within this range. So we are going to stop here. Okay, so now we move down to the second set, set B. Now, perfect squares greater than 1. Perfect square greater than 1. So perfect squares that are greater than 1, that means 1 is not inclusive, because 1 cannot be greater than itself. So now the list is going to be 4. 4 is a perfect square. All right. The next one is what? We have 9. The next one is what? So we have 16. But if you look at it now, you cannot list 16. You know why? Because the universal set is between 1 and 10. And just like I said earlier, that you cannot be a member of set B and you will not be in the universal set. It's not possible. You cannot be in Ogun State, or you claim you are from Ogun State and you say you are not a Nigerian. It's not possible, because Ogun State is a subset of Nigeria. So the same thing also applies to this. B is a subset of the universal set. So that means I can't list 18, because why? I can't list 16, sorry, because 16 is not in the universal set. So I'm stopping here. Hope you are learning from what we are doing here. All right. Now the next thing now is to find a complement. A complement. A complement. I told you earlier that A complement are those elements that are not in set A, but they are inside the universal set. All right. So now we can go ahead and list A complements. So those elements that are not here, but they are here, universal set. So now let's begin to list. Now we have 1, 2, 4, 6, 8, 9, and 10. Okay. Now when you look at these elements listed now, you will see none of them is inside A, but all is in the universal set. All are in the universal set, all right? So now this is complement of A, all right? So now let's look at this second part of the question, B. B complements. B complements. B complements. So I want you to try this. Let me see what you are going to have for B complement based on the explanation. If you can list those elements that belongs to this set, B complement. So now let's wait. Let's watch what some of you will drop now. Okay. Okay, I'm still waiting for a response. All right. I think I can see who by here. I have 1, 2, 4, 6, 8, 9, 10. That is for A complement. Now I'm waiting for B complement. B complement. B complement. Okay. B complement. All right. B complement. B complement. Okay. I can see one. All right. B complement. Yeah. Yeah. Okay. That's good. All right. So we have to move. We don't have time. All right. B complements. There are those elements that are not in B, but they are inside the universal set. We can go ahead and list. So now the first one is going to be 1, followed by 2, 3. You must not list 4. 4 is here. So we have 5, 6, 7, 8, 9 is here. You can't list this. So we have 10. So this is going to be the answer to that problem. All right, good. Now the next one we have there. Now this is not supposed to be B complement again because we have done that. Okay, so what we have here is number of elements. So number of elements in B complement. So that is what we have there. C is number of elements in B complement. Okay, number of elements in B complement. Okay, is anybody telling us before we do this? Number of elements in B complement. Anyone telling us? All right. Okay, so number of elements. So you just come here and count the number of elements we have here. So can we count together? 1, 2, 3, 4, 5, 6, 7, 8. So number of elements is what? 8. Okay, so that is what we have for that. All right, now let's look at the last one. The last one, this is C. Now the last one, that's D. All subsets of B, all subset of set B. Now when we say subset, subset is a set in another set. A subset is a set inside another set. Okay, so now let's look for all subsets of this set. So now the first is going to be the empty set. Empty set is a subset of all sets. Okay, please note that empty set is a subset of all sets. So now followed by a set of 4. Now a set of 9. Okay, because this set is contained here. This set is also in this. This empty set is here. And also we have a set is also a subset of a set. So this is a subset of this. Right? So these are all possible subsets of set B. So that is the answer to the problem. So now, how do we award mark for this question? Now, for writing out the answer, we have A1 for this, A1, 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 and B2 for this. Now, for you to get this, you must list everything correctly. If you miss out one, that's going to be 0. So you must get everything to earn these 2 marks. All right? So that is the answer to that. All right, so we are moving to the next question. All right, so before we do that, if you are yet to subscribe to this channel, ensure you subscribe so that anytime we're online, you will get the notification in time. All right, so now let's move down to another question. Example 3. Example 3. Now let's call U be the set of -3, -2, -1, 0, 1, 2, 3, 4, and 5. And X is the set of -2, -1, 0, 1. Y is the set of prime factors of 6. Prime factors of 6. Okay? Z equals to natural numbers. Natural numbers. Okay? So now we have lists members of sets Y and Z. Members of sets Y and Z. And the B, find Z complements. C, find Roman numeral 1 Y intersection Z, Roman numeral 2 Y union Z complements, Roman numeral 3 Y intersection Z complements, Roman numeral 4 number of elements in Y union Z complements. Okay, so now this is the question. Now let's solve this problem together. All right, now let's look at the problem. Now let's calling U be the set of -3, -2, -1 down to 5, and X to be the set of -2, -1, 0, 1. Now Y is the set of prime factors of 6. Now Z is natural numbers, set of natural numbers. So you have to list members of sets Y and Z. So now let's do that. Okay, so now set of Y. Now let's look at set of Y. Set of Y, prime factors of 6. Now prime factors of 6 are those prime numbers that will completely go in 6. When we say prime number, you know prime numbers. Okay, so they are natural number with 2 distinct divisors. All right, so we have 2, 3, 5, and what again, 7, and so on. So now among all these prime numbers, so which of them will completely go in 6? So now the first one is 2. 2 is a prime number and it's also a factor of 6. Now the next one is 3. 3 is a prime number and it's also a factor of 6. Of course, now we'll have thought of a 6. 6 is also a factor of 6, but it's not what? A prime number, so we can't list 6. So we are listing those prime factors. All right, now let's look at the next one. Z is the set of natural numbers, set of natural numbers. Now, so I'm going to list natural numbers. Don't forget we said natural numbers are counting numbers. So we have 1, 2, 3, 4, 5, 6, and so on. And then now by the time we are listing, we have to be very careful. Anything we are listing must be in the universal set. All right? So you must not list anything outside the universal set. All right, so now let's begin to list natural numbers. So we have 1, 2, 3, 4, 5. So we can't go beyond this. All right, so these are members of set Z. Now, the second part of the question, you have to find Z complement. Z complement. So now let's look at it. Z complement, that's the B part of the question. So Z complement. Z complement are those members of the universal set that are not in Z. So you are listing members that are not in Z. That is the meaning of complement. Please don't forget, complements are those elements that are in universal set but are not in set Z. So let's list. We have -3 is not here. We have -2, -1, 0. Okay, so this is where we are stopping. Good. So now let's move down to this C part of the question. Now you have to find Y intersection Z. Y intersection Z. So I think on this note we have to explain what intersection means. So if you have two sets now, and you want to find the intersection of the two sets. Now, what the question is requiring from you is you find those elements that are in the two sets at the same time. All right? So the set of members that is in set A and is also in set B. All right? So the elements that are in the two sets are the intersection of Y and Z. Now let's look at it. So we want to get Y intersection Z. Now all you just need to do, now go to the set Y and set Z. Look for elements that are in Y and are also in what? In Z. So what are the elements? So I can see 2 here, 2 is also here. So we have 2. So we have 2. Okay? So I can see 3 here, and we also have 3 here, so we have 3. All right, so that is the answer to that problem. All right, so now let's look at the next one. Y union Z complement. Y union Z complement. Now in mathematics, when you union two sets together, it means you add the members together. You bring all the members together. All right, that is the meaning of union. And when you are doing the union of two sets, you don't repeat numbers. Don't repeat members of that set, of the sets. Rather, don't repeat members of the sets. All right, now let's look at this. Now we have Y union Z complement. Y union Z complement. Now look at Y, this set Y, and this is Z complement. You want to union this and this together. So you are bringing them together. All right. So all the members here and the members here, we are bringing them together. So now let's list those members. So we have -3, -2, -1 is 0. We also have 2 and what? And 3. So this is Y union Z complement. So that answer this part. Now let's move down to the next one. Y intersection Z complement. Now we want to look for the elements that are in Y, set Y and set Z complement. Okay, intersection. Don't forget those elements that are in the two sets at the same time. Now let's look at Y. This is Y, all right, and this is Z complement. Okay, so now let's look for, do we have any elements that are in the two sets? No. So now the solution to this is going to be a non-set, or you say an empty set, because there's no element that is in Y and is also in what? In Z complement. No elements. So it's going to be a non-set, an empty set. Okay, so that answer that. Now let's look at this. Now, number of elements in Y union Z complement. Number of elements. Okay? Number of elements in Y union Z complement. So I just need to come down to Y union Z complement. Can you see Y union Z complement? We've done that before. So number of elements we have inside. So you just make a count. 1, 2, 3, 4, 5, 6. So the answer to this is 6. Don't forget, when making a count, if you want to write your answer, don't put your answer in a curly bracket because you have just counted the number of elements in a set. So you just write it as 6, just like the way we have it here. So it will be wrong for me now to put this 6 in a curly bracket because 6 here is not a set. It's the number of elements in a set. All right. So now I think that is the end of the question. So now how do we award mark to this question? Now you have to list members of Y and Z. So for listing correctly, we have B1 for this, B1 for Z. Now for finding the complement of Z, we have B1. And for doing this operation, Y intersection Z, we have A1. And also here we have A1. Now, Y intersection Z complement is a non-set. We have A1. Now, number of elements in Y union Z complement is 6. We have A1. So how many marks altogether? Let's count. 1, 2, 3, 4, 5, 6, 7. So 7 marks all together. All right. So I want to believe you are learning. Please, if you have not subscribed to this channel as you're watching, don't forget to subscribe and also tap the like button if the class is interesting to you. All right. So I want us to take one more before we end the class for today. Let's take one more before we end the class for today. All right. Now, given that calling U equals to the set of A, B, C, D, E, and L, and A equals to the set of A, B, C, D, and B equals to the set of C, D, F. Represent the information on a Venn diagram. Okay, now let's look at the question we have here, right? Now let's look at it. Given that calling U equals to the set of A, B, C, D, E, F, and A is the set of A, B, C, D, and B is the set of C, D, F, represents the information on a Venn diagram. All right. So, like I said the last time, that sets are represented either in a curly bracket just like we have here or on a Venn diagram. Okay. So now let's look at it. We have three sets. We have the universal set, set A, and set B. Now the first thing is to draw a rectangle which represents the universal set. So we have this. So this rectangle represents the universal set. Okay? So now, the next thing now is to draw a circle for set A and also set B inside this, completely inside the universal set. All right, but before I draw that, I have to look at the set given. Do we have any element that is in A and is also in B? So if that is true, then I have to overlap the circles. So the circles have to overlap. Now look at it. I can see C here and C is also here. So now see the way I'm going to draw the circles now. I have this will be the set of A and this set of B. Now, when you look at this area belongs to A and B. This area belongs to A and B. All right. But here, this is only A. You can only see A here. This is region of set A. This place region of only set B. But this region is for A and B. All right. So now let us look for elements that are here, that are in A and is also in B. The elements, the first one we have here, we have C. C is here and C is also here. So write the C here. Do we have any other elements? We have D here. Okay, and D is also here. All right, so that means we have D here. Okay, so now let us now complete each of the subset. Now let's look at set A. Set A. The members of set A are A, B, C, D. We have written C and D, so it remains A and B. So A and B will be here. Now I can't put A and B here. You know why? Because if I put A and B here, that means I'm saying that when you check set B, you are going to see A and B there, which is not true. So I have to put it here now. So I will not put it here where we have B. All right, now let's look at set B. Set B, all the elements we have there is C, D, and F. All right, so you have written C and D, remain F. So put your F there. So in such a way that when you look at this circle, the total elements you are going to have here is 3, which is the same thing with what we have there. That's C, D, F, C, D, F. Now look at set A. The total element we have there is 4. 1, 2, 3, 4. They are A, B, C, D. All right, good. Now, we now look at the universal set. All of these are inside the universal set. But when you look at the universal set, we have is a set of A, B, C, D, E, F. Now let us look at it. A, B, C, D, E. E is not here and it's not in A and B. So that means it will be outside. E, F. All right. So the total element inside sets, universal sets. Let's count 1, 2, 3, 4, 5, 6. So let's count all together. 1, 2, 3, 4, 5, 6. That means it's complete. We have A, B, C, D, E, F. So now what we have done now, we have represented this information on a Venn diagram. And this is where we are going to be stopping. So I want to believe you've learned 1 or 2 things. I'm so excited that you are here, and those of you that patiently waited for the class to end. So thanks so much. So in the next class, probably tomorrow, we are going to continue from where we stop. So if you have 1 or 2 questions or you have an idea you want me to know, make sure you drop your comments. Just drop your thoughts in the comments section. So thank you and God bless. Bye-bye.